Before we begin the webinar, let me introduce our guest speaker, Prof. Dr. Nohaniza Sarmin. Prof. Haniza is a professor in mathematics from University Technology Malaysia UTM Skudai Johor. She achieved her PhD in mathematics from the State University of New York, Binghamton, USA. Currently, she is teaching in UTM. Her list of subjects include Calculus 1 and 2, Linear Algebra, Discrete Mathematics, and Set Theory and Logic. She is experienced in research work and has over 100 publications, and has also supervised 48 PhD students. Without further ado, I would like to invite Prof. Dr. Hadiza Sarmin to share her knowledge with us. Please welcome.
Thank you very much, Muhammad Zahid Hakimi. Right? Assalamualaikum warahmatullahi taala wabarakatuh. And good morning, everyone. I cannot see the faces except for our MC, and I can see Dr. Yasar. I can see your names. Maybe you can type in the chat so I know which UiTM you are from, because I heard that they are quite not from just one, right? Yeah, Shuhaida. Okay. There's one from Segamat, right? UiTM Segamat. And from where else? You can type your, yeah. Oh, Tapa. Okay. Segamat.
Sabah.
Other than Tapah, Tapah is Perak, right? And Segamat. What about other UiTM? Just two? Okay. Okay, so that's from Perlis. I just came back from Perlis last week. So I gave a sharing also on supervision. Yeah. So welcome to UTM. Although you are not in UTM, I am in UTM. This is the class, real class in UTM. So just imagine you are in my class in UTM Skudai. Okay? Your lecturer, if you have Dr. Yasar as your lecturer, then Dr. Yasar had the feeling of studying in UTM before. And one day, maybe, if you have not been visiting UTM Skudai, maybe one day you can come. I think you are all like diploma or degree, right? So probably, especially if you are from Johor, you might want to continue your master's here or PhD here, who knows? So today I will bring you for more or less 2 hours, 1 to 2 hours, 2 hours maximum to my class. Okay. Okay, let me do this. This is the board. Okay, let me pin. I hope you can see clearly. Somebody has to talk at least, so I know that you can hear me well. Dr. Yasar, you can?
Yes, I can hear well.
Because teaching in Meet or online can be very quiet, right? So although the chat is quite far from me, I have my student here, Hannah, that will help me to read the chat if you write or typing or asking question in the chat. So you are welcome to ask any question while I'll share today's topic about relation and graph theory related to relation. So I believe you're all taking discrete mathematics. Yeah. So you have seen the first chapter normally on sets, right? Some of logic, some of proof. So you have also seen relation, I think, during school, during Form 4 or Form 5. How many type of relation that we have or we have studied or we have heard of. How many? 1, 2, 3, 4. For example, you have a one-to-one relation. You also have, you can just type in the chat. You have one to many. Yes. Fadlan said one to many. You have many to one. Yes. And you have many to many. Okay. Fadlan's, the lecturer needs to give extra bonus point. Okay. So first, what we learn in Discrete is a little bit different in how you write it. Okay, in how you write it. First, we want to see what is a Cartesian product. Cartesian product. Okay. Now, suppose we have two sets. You know what a set is? So you learn about set. A set is a collection of objects which is well defined. It's not just a collection of objects. For example, if I say that this is a set of all UiTM students taking discrete math, that is a set. Okay. What is not a set? Something is not well defined. Yes, sir. What is not a set? For example, a set of old women. Not well defined. Am I belong to the set? You think I'm old? Maybe not. So, grid line view, change the layout to spotlight. I don't know. I never used Meet before, so the admin can spotlight me. I normally use Zoom. Okay, I don't know Meet, maybe you have to do it yourself. You can click in the middle, there is a pin, right? You can also pin me, so you can see me clearly very big. That is how I see myself right now. Otherwise, you will all just see all the grid, right? Okay, we have 134 students in here. Yes, that's very good. It's clear. You are welcome to put in the chat anything related to the class, yeah? Not outside the class. Okay, so a set is a well-defined collection of objects. This is very important because you don't want to define a set of like beautiful women because it's not well defined. Some women are beautiful to the eyes of different people. Or old. How old is old? I don't think I'm that old, but I'm old. Yeah. So you have to have two. Suppose suppose A and B are two non-empty sets. We want to define a Cartesian product. Of A and B as, I hope you can see the writing, right? This is already font size 40. A cross B is a set of a pair A comma B in which A comes from A and B comes from B. Okay, now I have a question. If you have A cross B as the Cartesian product, is it equal to B cross A? Yes or no? Is A cross B The lecturers cannot answer, yeah? Just the students. Yes, Farah Izati, bagi dia satu bonus point. Okay, this is so A cross B, this is how we say it, A cross B. It's not darab, it's not multiplied by. A cross B is A comma B, but B cross A is B comma A, which is not necessarily the same. Okay? For example, I don't want to use just numbers because a set can be anything. Okay? What if my set is my favorite fruit? What is your favorite fruit? Okay, my favorite fruit is apple, orange, and give me one favorite fruit. Easy to durian. It's so hard to draw durian. Banana is easy, yeah? Banana is good. How do you draw banana? Okay. Suppose your set B consists of two elements. Shape. Okay, shape. Give me two shapes. Two shapes. Oi. Circle, square. Okay. I don't want circle because circle will be like my orange. What about love and square? Okay. Now I want you to write what is A cross B and B cross A. Okay. So how many elements in A cross B and how many elements in B cross A? How many? Dr. Yasser want to answer, but then lecturer cannot answer. Somebody who is brave enough, you can just turn on your mic and speak so I can hear and everyone else can hear. How many? How many elements? 3 times 2, right? Yeah, 6. Okay, so how do we draw? You have apple, love. Apple, square. Then you go to orange, love. Orange, square. Last one will be, if you write your notes using tab or iPad, you can just copy paste, right? Assume my banana is the same size and the same. Love and banana. The first element has to come from the first set. The second element has to come from the second set. So you can go 1, 2, 3, 4, 5, 6. But for B cross A, you have to take the second one first, then to go to the first. Yeah? So I erase this one. I erase the fruits. Okay? So you done with your B cross A? So B cross A is love apple, love orange. I also love banana. Let's A cross A. And square apple, square and square. You can see A cross B and B cross A, they are not the same. If you write just numbers, maybe it's hard to see the difference, right? So that's why I don't use numbers. Okay. Now, the order, we say the order of the set or the Cartesian product is the order of the first set times, this is the real multiplier, base numbers, times the order of the second set. So how many elements in the set A? 3. How many elements in the set B? 2. This is 6. But, not but, this is the same, right? Since this is numbers, right? The number of elements is just numbers. 2 times 3 is 3 times 2. So this is also 6. So the order is different, but the number is the same. Okay? Now, we are ready to define our relation. Before I define relation, try and list all elements of these two sets. Try to find and write A cross B. How many elements? 4 times 2, which is 8. Okay, somebody raise a hand. You have a question or you just want to raise your hand. Haris Nazril. Nazril Muhammad. Haris Nazril. Or tertekan, I don't know. Admin, you have to help me if there's a question that I cannot hear. You just turn on your mic, yeah? Okay. Tertekan, too excited. It's okay. Later on, you can demo. Raise your hand and ask question. Okay? List all elements. 1, 6, 1, 7, 2, 6, 2, 7, 3, 6, 3, 7, 4, 6, 4, 7. 8, yeah? So 1, 6, 1, 7, 2, 6, 2, 7, 3, 6, 3, 7, 4, 6, 4, 7. Why do we do this? Because a relation R from a set X to a set Y. So it's like a mapping, right? It's like a mapping. Is a subset of X cross Y. Look, you learn also about subset, right? R is a subset of X cross Y. What is a subset? You learn about a subset that A is a subset of B if and only if X in A implies X in B, right? This is the definition. A is a subset of B if whatever in A is in B. Or, I think you also learned about diagram, Venn diagram, right? Where you have the universal set, and then you have a set B, and the subset A inside. So you see, whatever element A in A is in B. It's a subset. So this relation R is a subset of X cross Y. Yeah. So R is in terms of set, which consists of elements like partly from here. Okay, so I can write R. Suppose I said R, define R to be XY in A cross B, such that X is a half of Y. I can give a relation like this. Okay, you have to choose elements XY in here such that X is half of Y. Which one? X is half of Y. This one, right? Only this one. So the answer is just 3, 6. I can also define R to be XY, X less than Y. XY, X less than Y, this will give all, because all X is less than Y, because that is my, it's all less than this. Okay? Another one, if I say, so you can write, I will erase, yeah? X less than Y. This is the whole one. Everything X is less than Y. If I change the question, bonus point. What is the answer? What's the answer? Type. How do you say there's none? You have to write R. You have to write R as a set. Okay, what is R? Yes, there is no element inside. So what do you call that set? Yes, Mu'arif. This is empty set or this, right? A symbol, right? Okay. Lulus. Semua boleh lulus. Okay, now let me give some example. Okay. I change the example. I add a little bit, yeah. You will give me the R. R is AB in A cross B. Such that A divides B. In symbol, we write A divides B, which means A is a factor of B. Can you write out the elements? A is a factor of B. For example, I don't write out all, yeah? 4, 1, 2, 3, 4, 5. There are 20 elements. 20 elements. You want to write AB such that A is a factor of B. So 1 is the factor of all numbers, right? 1 is a factor of all numbers. What does it mean by a factor? That this K integer such that A times K is. This is the definition of factor. 2 is a factor of 6 because there is a 3. 2 times 3 is 6. 3 is a factor of 300 because 3 times 100 is 300. Or you can divide the bigger one by the smaller one. So 1 is a factor of everything. That's why you have all the ones. What about 2? 2 is a factor of an even number. So pick even number. Right? 3. Find a multiple of 3. 3, 6, 3, 9. And last one is 4. So this one, what is the number order? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There is no formula. So this one you count. Yeah? So this is an example. Now, we are ready to see the properties of the relation. Okay? And for the relation, like I shared in the beginning, it doesn't have to be just numbers. It can be just a regular everyday relation. Okay, let me ask. Before you said there are 4 types of relation. One-to-one, one-to-many, many-to-one, many-to-many. Okay, what if I give you this question? The relations are A and B are set of humans, not extraterrestrial, yeah? Human, like us. Okay? R is a relation of this pair of humans in which A, B in R, A is the child of B. Okay? A, B in R if A is a child of B. Now tell me, which of these 4 relations? Is it one-to-one? Is it one-to-many? Is it many-to-one? Is it many-to-many? No points taken if you give a wrong answer. Which one? Type it, type it. A is the child of B. Nobody answered. If it's one-to-many, what's the answer just now? I missed. I saw one-to-many, many-to-one. Many-to-one cannot. You have a parent. How can be? You have a parent, right? A child has to have a mother and a father. So if it's you have a parent, right? Cannot be one-to-one. That means you have only a mom. Cannot be. Okay, what's the answer? Yes, sir. Do you have sibling? You have sibling?
Yes, yes.
If you have sibling, the other child belong to the same parent. Not one to many. It's a tricky question. So it is many to many, because this is the parent of this child. So this child is Yasa. Dr. Yasan. What's your dad's name?
Yusri.
Yusri. Your mom?
Nosia.
Nosia. You have brother or sister?
Yeah. Ama.
Ama. Si Ama tersedak dia hari ni. There's also another student in there or another lecturer. Maybe I could also make it bigger. Roniza here. My sister here. Another one, right? So there are many to many. You have to think, okay? If I put a husband of, that's, if you put one husband here, this is a husband 1-to-1, right? Okay, say this husband has one wife. Okay, so that can be 1-to-1. Yeah, okay. Shouldn't be example because for Muslim you can have more. Okay, anyway. Properties of relation. Okay. For the properties, I will use just one set. I will just use one set. A cross A. Okay. Now, the first property is reflexive property. Okay, reflexive is AA in R for all A in A. What does it mean? That means, for example, if you have A to be 1, 2, 3, 4, you have to have in the relation R 1, 1 is the king. 1, 1, 2, 2, 3, 3, 4, 4, among others. Okay, to be reflexive, it has to have the double, the twin. Okay, for all, if it is 1, 2, 3, 4, you have to have 1, 1, 2, 2, 3, 3, 4, 4. If you have 5, 5, 5 has to be inside. Okay, you have to understand this very carefully because later on I will give you some examples and you have to tell me whether it's reflexive or not. This is the easiest one. Okay, so in words we say that a relation is reflexive if it is related to itself. If it is related to itself. I can give you a relation that is not in a list I can give you R. AB in A cross A. A is less or equal to. Is this reflexive? Yes or no? Yes or no? Doesn't matter what A is. Is A less or equal to A? Meaning, can we have 1, 1? Yes, because 1 is less or equal to 1. Yeah, so the answer is yes. This is reflex. Since you have to write the answer or the reason why A is less or equal to A for all. If the question has no equal sign, okay? If I change without the equal sign, the answer is not reflexive because A cannot be less than A. Okay, so you have to read the question very carefully. Okay. The second one, this is recorded, right, Dr. Yasa? Okay. Good thing is you can watch it again if you miss. Okay. Now, the second one is irreflexive. Okay. A is not in R. You cannot have a pair or a twin. Okay, cannot have. Even one. Okay, so irreflexive. The third one is symmetric. Symmetric means if AB is in R, then BA needs to be in R. Okay? If AB is in R, then BA has to be in R. Dr. Yasar, they have learned about logic, right? The implication, the truth table. Yes? No?
For UiTM Segamat, logic is not yet.
Not yet. I will explain what it means later because normally chapter 1 here we teach about implication. Yeah? And the truth table. So I will mention it a bit because not all of you are. But I think they learn in school.
I'm not sure
I
about
think
that.
they learn, yeah, Form 4, Form 5. Yes or no? You learn logic in school, guys? Or you forget already? Yeah. See, they learn. Maybe they forget, but they learn, right? Okay, so I will mention again. Bagus lah, student. Yeah, lulus. Okay, this means if there is AB, BA has to be inside. If there is no, don't worry. Don't worry, be happy. Yeah? So you don't need to be worried. Okay. I will give you an example later to explain. Okay. Number 4 is asymmetric. Okay. Take note that if it is not reflexive, it doesn't mean that it is irreflexive. They are different. Okay? If it is not reflexive, you cannot say it is reflexive. The same thing is not opposite, yeah? It's not opposite. Like when you say hungry and full, they are not opposite. You cannot say you are not hungry means you are full, right? You are just not hungry, but you are not full. So you don't say, I'm full. No, I'm just not hungry, right? The same thing as positive and negative. The opposite of positive is not negative. Why? Positive means 1, 2, 3, 4. Negative means -1, -2, -3. What happened to 0? Nanya 0 ni. It's not positive, it's not negative. So the opposite of positive is non-positive. And the opposite of negative is non-negative. Okay, so opposite in mathematics is sometimes very tricky. All right. So this means, okay, let me show you example. Just now I will just show you one example. Maybe just this, yeah, maybe just this. Example of irreflexive is maybe this. I don't have a 1, 1 or 2, 2, right? So this is irreflexive. If I put in any one of these in here, it becomes not reflexive. To be symmetric, I can have something like this. Because if 1, 1 in there, if 1, 1 in there, terbalikkan pun 1, 1 also, right? So if it's just A doesn't matter. A is A. But if you have different 1, 2, you have to have also 2, 1. And maybe the rest, okay? So that is symmetric. If you have it, you have to have the other one around. Asymmetric means you cannot have a twin, 1, 1, 2, 2. Cannot have. Because it says if AB is in R, BA cannot be in R. Yeah, you cannot have 1, 1 and then 1, 1. Cannot be together. So you can have something like this. One thing is AA cannot be inside. And additionally, this one, you can have 2, 1. That's the difference. Still in here, there is no AA. But in here, you cannot have a 2, 1. This is not a symmetric because there is a 1, 2 and 2, 1. There's a 1, 2 and 2, 1. Cannot be together. Okay? Single 1, 2, 1, 2. So that is asymmetric. Okay, this is a little bit tricky actually, the asymmetric. Now, the next one is anti-symmetric. If you have AB in R and BA also in R, then A has to be B. Anti-symmetric. If there is AB inside and BA also inside, A has to be B. For example, there's a 1, 1 inside, AB, BA is also 1, 1, and A is B. So this is anti-symmetric. Okay, with this one example, let's go through this other 4 properties. Okay, with this one example, you tell me whether is this property or not. Okay, number one, is it 1, 1, yeah? Is this reflexive, yes or no? No. No. It has to be reflexive. Not only AA in R, for all. You see this? Oh, I have to circle. This is my A. This is my A. Okay? This is the R. It has to be 1, 1, 2, 2, 3, 3. Oh, dah terlupa dah. Forget, it's okay. Lepas vaksin ni ramai lupa ni. 1, 1, 2, 2, 3, 3, 4, 4. You know, Dr. Yasser, students, you cannot give easy question. They have to be given a hard question. Easy question, they make it hard. It's tricky. This is the easiest question. Okay, so now you remember, yeah? If you are given A to be 1, 2, 3, 4, to be reflexive, you have to have 1, 1, 2, 2, 3, 3, 4, 4. That's the rule. This one only have 1, 1. So it is non-reflexive. Non-reflexive. Okay. Okay. That's this one. If it's okay to you, you will click apa ni? Jempol. Okay. If it's not okay, you click. Tekan pula raise hand. Tu raise hand, tu salah tu nak tanya soalan. Raise hand kat mana? Oh, bukan bawah. Bawah tu raise hand. The emoji on top. Kan saya panggil nama kan nak tanya soalan. Okay. Sudah. Okay, now second question. Irreflexive. Yes or no? Irreflexive. Yes or no? Irreflexive means you cannot have AA. Cannot have AA. This is not AA. AA already. Okay? Cannot have AA. So the answer is no. You cannot have AA in R. This is my question. See, the question is too easy. Okay? So it is not irreflexive because for irreflexive, you cannot have AA. Okay? Cannot have AA. For all A. Or for any A. Okay. Tak lepas lagi ni. Dah 2 kali kosong markah ni. Third question. This one. Is it asymmetric? Yes or no? Cuba langsung jawapan salah. This one said, if AB is in R, BA cannot be in R. If AB in R, BA cannot be in R. But this one, this is A, this is B, right? AB, 1, 1 in R. BA is also in R, right? BA is also 1, 1. Cannot be. So it is not asymmetric. Tricky kan? Tricky. It's okay, don't worry. I will give another example susah sikit. I think you want a more harder example that you understand. Okay, last one. Is it anti-symmetric? Yes or no? Is it anti-symmetric? Yes or no? Asyik baik. Tidak saya bungkus. Yes, because if AB in R, yes, 1, 1 in R, right? 1, 1 in R. And BA in R, yes, 1, 1 in R. Is A is B, yes, 1 is 1, right? So the answer for this is yes. Actually, I haven't finished the property. There is a last property. People say save the best for last. Can you read when I write? Yeah, still, yeah. Number 6. Still boleh nampak, Okay. Transitive. Okay, transitive. Actually, this is the trickiest one. The rest, rasa dah susah, this is the trickiest one. If AB in R and BA in R, the A salah. If AB in R and BC in R, then AC has to be in R. I will explain. Actually, I need this definition when I give you the example. There's no more space. But it's okay, I can write on top. Yeah, I can write here. So not in my university last time, they put two whiteboard. So if it is already full, I can, maybe some other universities in Malaysia also you can tarik ke atas, pull up, so you can still read and you can still write. Okay, anyhow, let me give you one example. R equals 1, 1, 2, 2, 3, 2, 2, 1, 3. Say last one, 3, 3. Yeah. Okay, salin jangan tak salin. So only 1 hour. I need to give you a break, right? Toilet break. After this, you take a break, 5 minutes. 1 hour already. Okay. Okay, you got that already? 1, 1, 1, 2, 2, 3, 2, 2. Why I don't put 2, 2 first? Okay, just you can put 2, 2 here. Okay, ada yang marah pula, kenapa tak 2, 2 dulu? Okay, I can put 2, 2 here. Same, yeah? Don't erase, no need. It's okay, I just... Okay. I hope your answer will be right this time. Dekat benda kering ni. Is it reflexive? Yes or no? Is it reflexive? Yes or no? Okay, let me ask you. if you put a yes, let me ask you, what is your A? A is 1, 2, 3, 4. To be reflexive, you have to have all AA inside. Look for AA. Okay? For all A. So if you are given 1, 2, 3, 4, to be reflexive, no need to look at the example yet. You know that you have to have 1, 1, 2, 2, 3, 3, 4, 4. Do you have it here? 1, 1, 2, 2, 3, 3. There is no 4, 4. There is no 4, 4. So it is not reflexive. Understand? Understand? That's simple. Yeah? So those who write yes, now you know why. There is a 1, 1, 2, 2, 3, 3, but there is no 4, 4. So it is non-reflexive. Okay, just look at only the twin. Okay, so non-reflexive. Okay, that is the first question. But most of you, I think you got it right. You get no, right? So you understand. So reflexive means, look at your set A. You look at R, are all the pairs inside. Okay, all, not only some. Here you have 1, 1, 2, 2, 3, 3. But there is no 4, 4. So it is not reflexive. Okay. What about irreflexive? Yes or no? It's actually easy for irreflexive. You just look. Is there a twin? If there is even one twin, it's a no. Right? It's very easy. There's a 1, 1. Stop. No need to look at anything else. For this one, you need to look for all. Look for all. 1, 1, 2, 2, 3, 3, 4, 4. Right? For the second one, just look for, is there any one? There is a 1, 1. So, no, we cannot have any twin. Right? So most of you, I think all of you got it right. Okay, full mark for that. 1, 1. So you have to write your answer. It is not, okay, this one. Write it, write it. It is not reflexive because 4, 4 is not in R. That is the reason. Reasoning answer is probably 1 mark. Reasoning, the reason why is another 1 mark. So it is not reflexive because 4, 4 is not in R. Right? It is not irreflexive because 1, 1 is in R. Or 2, 2 is in R. Pick anyone. Or 3, 3 is in R. Just pick anyone. Next question. Is it symmetric? Look for each element. If you see AB, can you find BA? If there is an AB, can you find BA? If you said no, write Y. Write Y. If you said no, write Y. What's the reason? Yes. So you have to say, you have to write R is not symmetric because 1, 2 is in R, but 2, 1 is not in R. You have to write that. Because 1, 2 is in R, but right? 2, 1 is not in R. If you just write 2, 1 is in R, so what? If you write 2, 1 is not in R, so you have to say 1, 2 is in R, but 2, 1 is not in R. Yeah? What else? 2, 3 also, right? 2, 3 also. But you can just give one reason. No need to give all reason. Another reason will be 2, 3 is in R, but 3, 2 is not in R. This one you don't need to worry because they're the same, right? 1, 1 and 1, 1. No? Yeah. 3-1 is also not in R. So there are many reasons, 3 reasons why. No, not symmetric. Okay, what about asymmetric? Asymmetric, yes or no? If AB is in R, we cannot have BA in R. Think. Think before you write. Yes or no? It's okay if it's wrong. I will explain. Okay? Is it asymmetric number 4? Yes or no? It says, if you have AB in R, BA cannot be in R. Hey, tak ada siapa jawab? Yeah, that is right. Shakir Faizal. If there is a twin, definitely not asymmetric if there is a twin. Because 1 is in R, of course 1 will be in R, right? So, if you look at 1, 2, there is no 2, 1, it's okay. That one. But the problem is here. The 1, 2, the 2, 2, the 3, 3. So you can write a none for asymmetric. You cannot have a twin. Because AB in R, of course BA is itself. If AB is already in, BA is in for the same AA. Okay? Next, anti-symmetric. This can be extra bonus if you can answer this right. Yes or no? Yes or no? If AB in R and BA also in R, A has to be equal to B. Yes or no? Come on. Yes or no? Yes or no? Confused, right? Confused. Okay, you have to look every single one. Okay, anti-symmetry. If AB in R and BA in R, A has to be B. It doesn't matter for this one. You don't have to check because if 1 is in there, 1 also in there, 1 is 1, right? So you don't have to check this. You don't have to check this. You don't have to check this. Next, 1, 2. Do you see 2, 1? No 2, 1. So, also 1, 2 is inside. There's no 2, 1. So you don't have to check. You don't have to worry. It's okay. There is no pair. Right? If there is a pair, it is non-antisymmetric. Okay? If this is false, you're okay. Okay, so it's true. So this one, there is no pair, you are safe. It's okay. 2, 3. Do you see 3, 2? No. So it's done. 1, 3. Do you see 3, 1? No. If there is a 3, 1, they are not equal. So they cannot be anti-symmetry. It's a bit trickier for this one. Okay, last before we take a break. Yes or no? You have to check AB, then you check BC. If these two are the same, AC has to be inside. Okay? Okay, I repeat, yeah? If you have AB and you have BC, now compare the 2B here, it has to be inside, then your answer has to be AC has to be inside. Okay? If the B is not the same, you don't have to check. You only check the one that is the same. For example, you don't need to check 1, 1, or 2, 2, or 3, 3, or 4, 4. You need to check. Okay, it will go to the same thing. 1, 2, 2. Find a 2. 1, 2, no need to check. Because 1, 2, 2, 2 is 1, 2. 1, 2, 2, 2, 3. See? 1, 2, 2, 3. Do you see 1, 3? Yes. Okay, so you have to check every possible pair. This is the trickiest one. You should have to check every possible one. 1, 2, and 2, 3. Do you see 1, 3? Yes. Okay. Now you move to 2, 3. 2, 3. 3. There is no 3. It's okay. You need to check. Now you have to check here. 1, 3. 3. There is nothing. There is nothing. Start from 3. So the answer is yes. Yes. Because you can check only this. The 2 are the same. So the 1, 3 is inside. Okay. Clear, sir? Clear, yeah? Okay. Before that, I have to introduce you to, this is very important. You might be given a question, determine whether this relation is an equivalence relation. Okay, a relation is an equivalent relation if it's reflexive, symmetric, and transitive. Okay. Okay, let me see. And also partial order relation. Partial order relation. Another one. I will erase this. A relation is called a partial order relation. It is reflexive. Anti-symmetric and transitive. Okay, that's the difference. Okay, now let's see. I give you A. A is 1, 2, 3, 4. I don't have time to give you a lot of examples, but let me just give you this one, yeah? Okay. Okay, this one. One, 2, 3. 1, 3, 4. 1, 1, 1, 2, 1, 3. 3, 1, 3, 3, 4, 4. Okay. Try to answer whether it is reflexive, irreflexive, symmetric, asymmetric, anti-symmetric, and transitive. Okay, number one, yes or no? Reflexive. For 1, 2, 3, 4. Yes or no? I hope all of you got it right this time. So you see, things are right. Do you see tutu? Do you see tutu? You don't see
No.
tutu. See? That's the trick. Yeah, Zara, that's the trick. There is no tutu. So don't look at just 1, 1, you see 3, 3, 4, 4. There is no tutu. So this is not reflexive. The answer is no. Because tutu is not in R. Okay, number 2, is it irreflexive? Is it irreflexive? Yes or no? Because there is a 1, 1, right? Or there is a 3, 3, or there is a 4, 4. Okay? Okay, good. Number 3, is it symmetric? Yes or no? If it is no, why? 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 1, 2 is in R, but 2, 1 is not in R. Farah Izati, full mark. Okay. Now, this is not symmetric. Don't say this one. Don't use this one as the example. Use this one. Okay. Now next, asymmetry. Yes or no? Asymmetry. Number 4. Yes or no? No, why? If there is a no, why? Because there is a 1, 2, and there is a 2, 1. There is not. There is a 1, 3, there is a 3, 1. Or you can use practice. You can use 1, 1. 1, 1 is in there. Of course, 1, 1 is in there. But you cannot have the A inside. Yeah? Okay. What about anti-symmetric? This is a little bit harder than 4. Yes or no? Number 5. Anti-symmetric, number 5. No, why? Zoratu? Why? Because 1, 3 is in R, 1, 3 is in R, and 3, 1 is in R, but 1 is not 3, right? 1, 3 is in R, and 3, 1 is in R, but 1 is not 3. You have different, we call it different pair. Different twin. Last one. Okay, last one. I hope you can answer it right. Positive or not? So we don't have to look at this twin. You don't have to look at here. It's okay. No need to check. You check only this one. 1, 2. Is that a 2? No. There is no. So it's okay. 1, 3. Is that a 3? Yes. Right? 1, 3, 3, 1, 1, 1. Is it inside? Yes. Okay. Next. 3, 1. Is it 1? Is it 1? Yes. 3, 1 and 1, 3. 3, 3 is inside? Yes. Okay. So you just check anything that is possible. The 1, 2, you don't have to check because there is no 2 something. Right? 1, 3, 3, 1, 1, 1, is it inside? Yes. 3, 1, 1, 3, 3, 3, is it inside? Yes. Okay, so the answer is yes. Yes. Good. Okay, so we have to move on to what we call the graph theory. I will introduce first the diagram of the relation. And I'll just mention a little bit about graph theory and then the application. Yeah. Okay. Now, we call it the diagram of the relation. My set is still 1, 2, 3, 4. I will give you the R and I will draw the diagram. Okay. I will give you the R. 1, 1, 1, 2, 1, 2, 2, 3, 3, 4, 4, 3, 4, 4. Okay. We will draw a graph. Now, a graph, normally graphs, you can use G or gamma as graph. Consists of vertices and edges. Okay? Graph consists of vertices and edges. In our case, our vertices will be 1, 2, 3, 4. Okay, 1, 2, 3, 4. So I will draw 1 here, 2 here, 3 here, 4. You can put the vertices however you like. But normally we want to put like in a circle. You can put like you can also put like in a circle. Yeah. Okay. Now I will draw the edges, what we call the edges. So this is the vertices. And the edges. Now, 1, 1 means you have the edges from 1 to 1. Okay? From 1 to 1. 1, 2 means you have from 1 to 2. And then you have also from 2 to 1. Okay. Now 2 to 2 is what we call a loop. And this graph is a directed graph because there is a 1, 2, they might not be 2, 1, right? So you have to have a direction. Okay, so 1, 2, 2, 1, 2, 2, then 3, 3, and then 3, 4, and then 4, 3, and then 4, 4. Okay, so this is the diagram of the relation. Very easy, right? Okay, very easy. Okay, you see, from a graph, it's very easy or easier to determine whether it's reflexive, right? Because if you see all loops, if you see all loops at the vertices, then it is reflexive. You see, right? Reflexive. Then you can check further. For symmetry, you look at, if you have this one, you have to have a pair, the other one. If there is none, it's okay. But if you have this, you have to have this. And if you have this, and then you have this. So this is symmetry, also easy. This one you don't have to look, but okay. I will give you two examples. Yeah? There's another one. Relative you cannot check from the diagram. For the others you can check. Okay, the second example. Okay, the second example is 1, 3, 1, 1, 3, 1.
Medium, suara medium tak dengar.
Prof, mute. Prof, mute. Prof,
Audio
mute.
tak dengar.
Somebody mute me. Hey, I was away from the laptop. What can I mute? What about just now? Just now is okay? Baru
Okey,
ada?
medium.
Oh, Yasa mute saya. Okay. Okay. Sorry about that. It's not my fault. I'm away from the laptop. Okay. So, the vertices, you look at A, yeah? For the vertices, 1, 2, 3, 4, you look at A. Now we draw 1, 1, 1, 3, 3, 1, 1, 2, 3, 3, 4, 4. Okay. Sometimes we draw the vertices so it didn't intersect. That's why sometimes the vertices is not like 1, 2, 3, 4. You can go like 1, 4, 3, 2. Okay, so it don't intersect. This one is okay. This is definitely not reflexive, right? Because there is no loop here. So you can see very easily. It's not symmetry because there's one way, there is no other one. Okay. Okay. Last one. This is the easiest one. Okay, this one. But students don't like easy. They like the hard one. Okay, I give you 2 minutes to draw. 2 minutes to draw. Maybe 1 minute you will tell. Okay, so 1, 2, 3, 4, 1, 2, 3, 4. There is no 4. Stop. Okay. Okay, so it is not reflexive. There is no 4-4. It is symmetry because you look, it's okay, but you don't have any other that you need to check. This is also transitive. You can check because there is no connection, right? You don't need AB, BC, and AC. There's no connection. So you can check all properties. Okay,